So in this example, they're talking about deer. It says in 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially. So we're going to need an exponential model. So let's think about that. Write an algebraic function n of t representing the population n of deer over time t. Okay, so we're going to be looking for n of t. So 2006, we started with 80 deer. Okay, so we know the initial amount of deer. There were 80 of them. We let them loose running around. So n of t is going to equal 80 b to the power of t. What we don't know is that b, and we need to figure out that growth rate is what we're trying to figure out. Well, we know that in 2012, the population had grown to 180 deer. So we know that after 6 years, right? So from 2006 to 2012, so t is 6. When t is 6, so n of 6, that is 180 deer. And that has to equal 80 b to the power of 6. Okay? So hopefully that makes sense. I kind of threw that 180 in the middle, but that's the population. Maybe I can write that better. Maybe this looks better. 80 b to the power of 6, right? Just putting in 6 for t. But we know the population in 6 years is 180. So maybe that looks better that way. Okay, now how do we solve for b? Well, first you divide both sides by 80. So let's do that. And then on the left-hand side, that's going to be, let's see, 9 over 4. If I divide them both by 20. So this goes back to when we had exponential equations and root equations where we're trying to get rid of that exponent. So hopefully that brings back a happy memory, but we need to get rid of that 6, and we're going to do that by raising it to the power of 1/6, or taking the 6th root. But I'm going to do it as a fraction. That'll be easier to put on my calculator. Okay, so then this is going to give me, oops, scroll up. Okay, on the right-hand side, I'll just have b, and then I'll have to figure out what this equals. So in my calculator, I'm going to go parenthesis 9 divided by 4, and then I'm going to raise that to the power of 1 divided by 6. So that's actually what I'm going to put in my calculator. Let's see, 9 divided by 4, and I put the parentheses, to the power of parenthesis 1 divided by 6. Okay, and I'm getting, it's approximately 1.144714243. That's what my calculator is showing. And I'm going to go to 4 decimal places, so right here. So my b would be 1.1447. My model then, if I just scroll up a little bit, my model is going to be right from here. It's going to say n of t equals 80, and then my b I just figured out is 1.1447 to the power of t. And then I could predict what I think the deer population is going to be in 2030, or whenever I want to know how many deer there are. A note, the book states this, and I want to bring it out. It says, note, unless otherwise stated, do not round any intermediate calculations. So like when we were doing this part, we're not rounding that off, or this part, we're not rounding that off. And then round the final answer to 4 places for the remainder of this section where we're working with exponential functions. I will tell you though, when we're working with money, we go to the nearest penny. Okay, so